Alright, this video is going to take us back to solving absolute value inequalities. I feel that we need to have a little bit more practice on this before we move on. Just kind of a little reminder about how we solve these types of inequalities and our methods, ways we set it up, and the ways we solve it. So let's recall that when we have absolute value inequalities, we must follow these rules. Okay? Let's take a look at our first rule, this one right here. If the absolute value of ax plus b is greater than c, c of course being greater than 0, which means it is positive, then it is equivalent to setting it up two different ways. Our ax plus b, or the inside, will be greater than the negative c, and the inside, the ax plus b, will be greater than the positive c. And our second one, if our absolute value of ax plus b is less than c, again c being greater than 0, that is the same thing as saying the inside is less than the constant, or the inside, the ax plus b, is greater than the negative constant. We use the same methods for our inequalities that we used when we were doing our absolute value equations. Remember, the first thing we did was to isolate the absolute value expression if necessary. Remember, it's not always necessary. Then we rewrite it using the compound inequality. Remember, this is where we do our split, okay? Using our rules. And then we proceed then to solve each one of those inequalities. Alright, so let's start here with our first one. We have the absolute value of negative 4q plus 2 greater than or equal to 10. So first thing I'm going to do is the absolute value isolated, and the answer to that is yes. So now I'll focus on my inequality symbol, which is the greater than or equal. So that falls under this rule here. So I'm going to do my rewrite. So that means the negative 4q plus 2 will be less than the negative, and we must include our equal, the negative, so that would be negative 10, or the inside, the negative 4q plus 2 will be greater than the constant of 10. So we can then proceed to solve these. We will subtract 2 on both of them. So we end up with negative 4q here, less than or equal to a negative 12. And over here we end up with a negative 4q greater than 8. And again, don't forget your equal sign. So let me back up and put that on there. That's what was throwing me. All right, we'll continue. Then we're going to divide that negative 4 out. So now what happens? Remember, when we divide by negatives, we will reverse the symbol. So that means here the q will become greater than or equal to the 3. And over here, the q will be less than. The q will be less than or equal to negative 2. So now we want to go down here and put that on our coordinate plane. Or not coordinate plane, sorry, our number line. So here we've got our 0. We'll start with the negative, we'll put in our negative 2, and let's put in our 3. So somewhere along here. We do have the equal sign, so in both cases they will be closed points. If we look at the q greater than or equal to the 3, we would shade greater than or to the right. And the less than or equal to the -2, we will shade to the left. All right, let's take a look at another one. Now we have the inequality. The absolute value of 2x plus 7 divided by 3 is less than or equal to 1. So right off, I hope that you noticed that your absolute value is not isolated. So we must, first of all, get it by itself. That means that 3 needs to go. It's in the denominator, so we will multiply both sides by 3 in order for it to cancel out. So we'll cancel it out. So we'll end up with the absolute value of 2x plus 7 less than or equal to 3. Now we focus on the symbol. It is a less than or equal, so we will go with this, our second one. We will go with this one. So we will have the 2x plus 7. The inside will be less than, and again we must include the equal, the positive. And the 2x plus 7 over here will be greater than the negative constant, greater than the -3. Let's go ahead and solve them. We'll need to subtract the 7. So we have 2x less than or equal to a -4, and 2x, those are gone, greater than or equal, did it again, a -10. Solve them both by dividing out our 2. So we have x less than or equal to a -2, and we have x greater than or equal to a -5. Now let's come down to the coordinate number line. So here's our 0. Let's put in our -2 and -5. Our x is less than or equal to -2. So again, we will have a closed point, and we are going to shade to the left. I'm going to stop right there because I do see my other endpoints. I'm going to check that out. X is greater than or equal to -5, so I'm going to close that point. Greater than, I'm going to shade to the right. And here we have this small little interval that is our solution. Alright, I'm going to post along with this new video some questions for you to practice more on these, and those will be due at the beginning of class.